My name is Rishabh. Thanks, Barbara, for the introduction. Again, very happy to have this CoRise session. Again, right, it's a great opportunity for me to think about like how RecSys changes in the new world of LLMs. I think so again, the background over here is that we've been having these courses on large-scale recommendation systems, the multi-stage pipeline of RecSys stack as part of CoRise, and we've been doing a couple of runs of that already. And now is the time to revisit some of that in terms of the new transitions in the world which have happened, especially in the generative AI front. So I think like we thought a lot of you might have attended the courses, or a lot of you might have already signed up for the next run. We thought just to take a half an hour in between one of these runs and then see what's going on in the LLM land, right? And then just get on the same page on some of the advances which have been made. So I thought like we'll compile like a very short presentation. It's not going to be like very long, just a few pointers on what's going on and like a few personal thoughts which I wanted to share. Just a quick background. Right now, I'm at ShareChat based in London. I did my PhD in machine learning at UCL in London. And up until last year, I was at Spotify doing marketplace recommendations. I also had a startup, like very briefly, just around my PhD time, usercontext.ai. And maybe now is the right time to bring it back to life at some point as well. So yeah, we're going to look at a few of these topics today. We're going to talk about 4 broad themes. One is just for the people who haven't been like used to RecSys, just a quick overview of what we mean by multi-stage RecSys stack. Then we're going to talk about like in the world of LLMs, what sort of formulations we can do for the recommendation problems. We're then going to look at 4 to 5 recent published work from across industry and universities on this topic. And then I'm going to just share like a bullet point list of some personal thoughts on the implications of the RecSys stack, especially now that a lot of generated content is around. Yeah, so I think we're just going to start with a quick introduction on the recommendation problem. The core challenge over here is what to show to users, right? There's a user, there's a bunch of items over here, and will the user like this item? Will the user like the other item? What the score of this user item pair looks like? So I think the problem here is that, especially if you have a large content catalog, how do we score user item pairs so that we know that which content the user might be interested in, and then I can recommend that to the user. And just a quick background, right? There's a lot of challenges in the recommendation problem. One is the content space. What do we know about the content catalog? How big the content catalog is? If you look at the Netflix of the world, we're looking at 50,000 movies. Spotify, Apple Music, maybe 100 million music tracks. If you look at Reels, ShareChat, or TikTok, we get 100 million items per month. So the content space varies a lot. On the user front, we have to keep on understanding and like fine-tuning our understanding of what do we know about the user intents, user personalization. On the context side, what do we know about the current session, the current need? How do we pick the top key items to show to users? How do we evaluate that? Did we do good stuff? Did the user like it or not? Did the model is learning okay or not okay? And then finally, on the interaction side, that once we decide to show these recommendations, how do we learn from user interactions? How do we update our models? How do we increasingly improve the system to make the user happier and happier? And overall, how do we do this across like a large amount of users and large amount of content pieces within the latency requirements which we have in most of these industrial platforms? So that's the background on what the recommendation challenge is about. And in general, what people have done is we've developed this multi-stage RecSys stack, which is fairly common across the industry at this point now. And just to give a quick background on what the multi-stage RecSys system looks like, we have a huge corpus, right? This is from a RecSys paper now like almost 7 years ago from YouTube. This is a very similar hierarchy, similar framework of how most of the modern RecSys systems are designed. Again, some deviances on the real-time monolith style architectures. We're not going to cover that today. But if you look at the multi-stage pipeline, we have a huge corpus, which is a corpus of videos or podcasts or images or music, whatever be it for your platform. And then the candidate generator's role is to subselect a small number of items so that the ranker can rank. So the candidate generator, the goal is to go from, let's say, 100 million items to maybe a few thousand items so that the ranker can work on top of it. Now, the candidate generator does leverage user history and user context, and they could be like many candidate generators. Finally, when we go from millions to a few thousands, then I bring in the sophisticated machine learning model, which is a core ranker. And the ranker can now consume a lot more richer features because now you're calculating these features only for a handful of 1,000 examples and not for the 100 million corpus size you had. And the ranker can consume items from like many candidate sources. And finally, once you do that, you decide the final ranking and you show that to the users. So that's the typical flow of what a multi-stage recommender system looks like. I think towards the end of this talk, I'm going to come back to the corpus is the first part that, hey, what is the corpus from where you're picking up items? This is a candidate generator which selects a few thousand items from 100 millions, gives to the ranker, and finally the ranker selects maybe a few tens and hundreds and then shows it to the user. So that's the typical flow of a multi-stage RecSys pipeline in general. We go from tens of millions to a few tens on the real estate, on the feed of the user on your application. So that's a quick background for people who may or may not be aware of the entire RecSys stack in general. Now, what we're going to do is I'm going to assume some default knowledge because we don't have the scope in this talk to go talk about what LLMs are. So I'm going to assume that you're aware of LLMs, you're aware of what prompting means, you're aware of a bit of what fine-tuning might mean. So at least like some common understanding of these terms is assumed in this talk. And if not, then please feel free to revisit after you've had and there's a lot of like amazing resources out there which would talk about this in far more detail and a great exposition than I ever would. So we're going to assume that like we now know about what RecSys is. We have a bit of understanding about what large language models are. Now we want to talk about like how do we formulate a recommendation problem in terms of the language models. So there's a very nice survey which I've linked over here, which talks about like how large language models can be used in the RecSys formulation. So specifically, it's talking about three things. The three things are listed on the right. We're going to go through them one by one. So the first is I'm just going to use the LLM to just give me embeddings. And then these embeddings just serve as a normal feature for me. And I'll have my own ranker, my own RecSys stack based on the candidate generator, based on the ranker. It has a bunch of features. And then I'm going to use it. But then as part of the LLM output, what I'm going to say is that, hey, I have these items and these users. I'll pass them through the language model, get these embeddings, and then use these embeddings as features. So that's the simplest approach of classifying how RecSys and LLMs work together, which is just use the LLM, get the embeddings, use these embeddings as features, and just continue with your generic RecSys stack, which you had before the LLMs were this popular. The second one is that, no, I'm going to do something else as well, not just the embeddings. I want to use the language model to generate some tokens for me. Because again, LLMs are trained on the sequence generation task. And again, they're generative models. So essentially what I want to do is I want to provide them input of the users and items. How do we give these inputs? We're going to see later in the lecture. But if I provide them some of these inputs, then they will generate a bunch of tokens, right? Now what I want to do is I want to look at the features we had, the embeddings we had, and these tokens, and then pass it to my RecSys system. So again, this is slightly different than the embeddings, that here we're not passing tokens, we're just using the embeddings of content we already have. Here we are passing in tokens. And finally, the third stage, the third categorization could be that I want to use the LLM itself as the ranker. So here the goal is that I will try to do some prompting, try to do some instruction tuning. We're going to talk about that in a bit. But then I don't have a separate ranker model at all. All I have is I have this language model, be it GPT or be it Llama, be it Alpaca, like all of these models. I want to use any one of them as a black box and then get my results. So that is like LLM as a recommender system itself. So there's three broad categories in which we can use some of these things. And again, there's a bunch of work which has been going on. Because again, by no means you're going to be covering all of it or even like a half subset of it. But this is just to show that there's a lot of work going on in the BERT style world, which was the generative, which were like these language models up until the generative language models started coming in. So there's a long series of work on this topic. We're not going to cover all of them, but then just to get a sense of how should we be thinking about some of these before we go into some specific examples. If you look at the broad categorization of like how language models and recommender systems have been linked together, like you can look at two main categories. One is a discriminative LLMs and the other one are generative LLMs. Now, discriminative LLMs are typically BERT style models, right? Again, right, way before the GPT models came in, BERT had been a common architecture choice for sequence modeling, for these embedding generations. So they provide the embedding backbone for downstream models. And essentially what they allow you to do is it allows you to align the representations of these pre-trained models like BERT with your domain-specific data, and you can do fine-tuning on top of it. So again, these are just encoder-only models which are not going to do generation for you. So that's one type of LLMs which have been around, and like people have used BERT inputs and like some of these models as part of the RecSys stack. The second type of formulation is more on the generative side. Here, the goal is that, hey, I want to generate, again, it's not just I want to decode as well. So then essentially what we do is we formulate RecSys as a natural language generation task. And here we are generating the recommendations. So I think that's the difference between the discriminative language models and the generative language models, and especially the GPT-based models, the ChatGPT and all these variants, they are around generative modeling. So then I can formulate my recommendation problem as a generative task. And then there are a few ways of looking at it. Tuning, non-tuning. If I'm not doing any tuning, then I can just either prompt it, do some in-context learning. We're going to look at a couple of examples of some of these later, or I can just do some prompt tuning, instruction tuning, and then the rec tuning in terms of how we can work around with generative LLMs. So again, if some of these phrases don't really intuitively apply in your RecSys ideologies, it's fine. We're going to look at some examples to make the exposition a bit clearer. But then overall, we're talking about a lot of work which has gone into bird cell model, a lot of work which has gone to generative models and how they fit together to apply to RecSys in general. Now, with this background, let's look at some specific examples of what's been going on, and then we can talk about some implications. So we're going to talk about 4 of these approaches. The first one is just zero shot, essentially. So can we use these language models as a zero-shot ranker? If we, again, these are like increasing level of sophistication, if you may. So I can say that, hey, let's start with like simple, we do some zero-shot, or hey, I want to start prompt tuning a bit. What sort of prompting can I do? What sort of advances can I make there? So there's a couple of examples. We're going to talk about pairwise prompting as one of these novel advancements which have been made. Then you mature into the tuning world. There was a very nice paper which recently came about on rec tuning. People have done instruction tuning a lot. There's a corresponding work on rec tuning, which is recommendation-specific tuning. And then beyond that, how do we use it for personalization? How do we use it for representations? So in the next few slides, we're going to look at one example of each of these and then talk about how they've been performing. Yeah, so let's start with like zero shot, right? Here the goal is that, can I use an LLM as a zero shot ranker? So again, this is again, May 2023, just very recent paper from Julian Macaulay's group at UCSD and London University in China. So here the problem which was formulated as, can I use LLMs as zero shot rankers in general? And essentially here, right, the way the problem has been formulated is that I'm going to do the recommendation formulation as a conditional ranking task. So what I'm going to do is I'm going to say that, hey, the conditions are the sequential interactions users have had. So if a user has had, let's say, 50 interactions on your platform, right? So then I can use this starting interaction and leverage them as prompts. I'll have a bunch of candidates, which could be retrieved by the candidate generator we talked about. And then what I want to do is I want to ask the language model, give me some outputs, right? So essentially, this is, again, there is a few different types of prompting people could do. 3 of them are mentioned in this paper. The first one talks about just sequential prompting. Essentially, what you're looking at is you're looking at the user history as a sequence, and then you just provide it as a prompt that, hey, this user has watched the following movies in this order. And that's, again, and based on that, what could the user be liking, right? So this is a way of prompting based on sequences. Another prompting strategy talked about here is like recency-focused prompting, wherein in addition to just sequential interactions, you're also adding some information on the recency, right? That, hey, I mean, in the recent past, I watched this movie and I liked it. The other aspect over here is in-context learning. Now, ICL, which is in-context learning, is a very prominent prompting approach, because what it does, it provides one sort of feedback in the model, right? It says that, hey, I've recently watched some of these movies, but since I've watched this, you might want to recommend me one of these movies because I've watched one of the other movies, right? So you're providing that within context learning. You're in your prompt saying that, hey, because the user has watched movie A and B and I really liked it, C is a good movie to recommend, use this as a context and then provide the answer to me. So I think like this work looked at how do we, without changing anything on the language model side, how do we look at some prompting strategies to generate recommendations? And essentially the flow over here on the right figure shows exactly that. I have the interaction history of the user. I can trigger the LLMs to look at some ordered sequence by designing these prompts. And the prompts could be sequential or recency focused or in-context learning. And then I, in general, like in the candidate generator phase, I retrieve a bunch of candidates, provide them together with these prompts, and then ask the GPT model or like these generative models, the LLM model, to provide the order of in which like I should be ranking. So that's one way of recommending, right? And there's quite a few good learnings from this, right? Here, the authors mentioned that LLMs can utilize sequential historical behavior, but they are really struggling to respect the order of the interactions. And in general, there are ways in which you can work around it if you want to give respect to the order. Like the examples could be in context learning or recency-focused prompting. And in general, they found that again, if you look at the results on the right as well, you start seeing that if you look at one of the other baseline models, SASREC, versus this specific model, SASREC still performs much, much better in general. But then if you look at zero-shot cases, zero-shot is like there's no specific training. Even in the SASREC model, then for zero-shot examples, this model is fairly competitive and almost outperforming. And in general, the authors observe that LLMs do suffer from a bunch of biases, including position and popularity biases. And then there needs to be some ways on mitigating that. We haven't solved that yet. The figure on the right bottom shows that if you look at the NDCG results, the bigger the model, the better the NDCG metrics turn out to be. So I think like the model size, especially in the parameters, bigger models have resulted in like better NDCG performance. No surprises there at all. So the quick summary over here is that this is the simplest case, right? I have LLM and I can just do some prompting based on some of these examples and then see how that works. And that sets the baseline that these are the other RecSys approaches I have. Here is an LLM base as a baseline, and it works decently in a zero-shot scenario and not so much in like typical RecSys systems in general. So there's still, again, RecSys as a problem is not solved as LLM, but specifically in the zero-shot case, it works much better. Now let's do something slightly more non-trivial, right? Up until now, we are doing simple prompting, and now let's talk about pairwise prompting. So again, this is a very nice work coming in from Google research team, and the paper is around rankers with pairwise ranking prompting, essentially. So we've looked at a couple of examples, right? The prompting which we did was point-wise prompting, right? If you look at the first example on the left, it says that, hey, there's a passage, there's a query, does the passage answer the query? So this is like a yes or no answer. So it's like point-wise. Similar, right? I can say that, hey, in the history of the user has watched these movies, do you think the user will like this specific movie or not? And then you get a yes or no. So this is point-wise. I can also prompt the model to say, give a list and then ask it to output the ranking order, right? That here's a list of movies users had liked in the past. Here is a list of candidates. Just can you rank them for me, please? And in general, the LLM can output a ranking over there. Now, there are two problems here, especially in using some of these prompting strategies for recommendation. The first is in the point-wise world, it's not calibrated because here you do want to use the score of the model, and the model scores need not be calibrated at all. And that creates a problem, especially if you're going to do some sorting later on. Because if you, again, the way to use a point-wise model in recommendation ranking would be you run for each of these candidate items, you run it through the point-wise prompting strategy, get a score, and then use the score, sort by it, and then you get the ranking, right? Now, if these scores are not calibrated, then there is no way you're able to do that sorting. In terms of the list-wise, like the LLMs suffer from a few different problems, wherein they might just only partially output the list of documents you provided, or they do some irrelevant outputs, or maybe they do some replications. They provide just the same document at different ranking, and also they're like fairly inconsistent. If you prompt them again, change the sequence, then it's going to re-rank differently. So there are a few different problems with like point-wise and list-wise prompting, and that triggered the authors to propose this instead, right? This formulation is more of a pairwise ranking prompting. And here, the one example could be that the query could be that, hey, this is a specific query. There are two passages, passage A and passage B. And then the question is, okay, which one is better? Do you think for this query, is passage A better or passage B better? So again, this is very similar to a recommendation task wherein like you have the user history, and then you want to ask, hey, is item A better for this user than item B? And essentially here are two modes, right? One is you can just ask the output, or if you're working with like open source models, you can get the score as well. That give me a score for the target to be passage A or target to be passage B, and then I can do a pairwise comparison of the score itself. Now, the question then becomes like, how do you get these scores? So there are like ways in which people have calculated these probabilities, right, from the language model itself. So again, like one assumption people have made that let's assume that the passage prior is uniform, and if it's uniform, then at least in the condition probabilities, in the Bayes rule, I can just get rid of one of these factors, and then I can estimate the log of query given the history using a pre-trained language model to compute the average log likelihood of the questions. So I think, again, there's a very nice summary in this specific paper from 2019, 2020, I think, which talks about how do you get these scores with these models. But assuming you're working with, again, you won't be able to get that in a GPT API, but then if you're working with, at least to the best of my knowledge, but if you're working with like open source models, you will be able to extract some of these scores. Now, once you have these scores, then you can do pairwise swaps, right? You can start with the sequence and then do pairwise comparisons, and based on the outcome of the pairwise comparisons, do these swappings, and then finally get the entire ranking list together. And once you do that, it seems to perform like really well, because especially in the Trek 2019-2020 task, in the zero-shot case, especially in Trek 2020, this pairwise prompting was outperforming almost, as opposed to like most of these BM25 and the BERT-based models as baselines. So again, we're seeing consistent trend that in zero-shot cases, these are like doing really well. Even in the non-zero-shot cases, right? The performance over here is like fairly competitive and like even better in at least in the Trek 2020 task list. So what the quick summary over here is that we've looked at simple prompting, we have looked at the problems with simple point-wise prompting, and then here is an approach of doing pairwise prompting, wherein you provide a bunch of pairs, ask the models to output. Let's go further beyond and say that, hey, what beyond prompting should I be looking at? So instructing tuning is something which is fairly common, and a lot of people have been doing that already. And here is a RecSys version of it, right? So in this paper, which came in very recently, as earlier this month, this talks about instruction tuning plus rec tuning for the recommendation challenge, right? So how do we align large language models with recommendation? And the authors provided an additional rec tuning step. So essentially what happens here is, if you look at the traditional problem we've been facing, right? We have said that there is a user history, I get a new item, I can just prompt that, hey, tell me, will the user like this new item or not? So that's what we've been dealing with so far. But instead, let me do some fine tuning, but in a recommendation scenario. So essentially what instruction tuning does, right? It provides instructions to the LLM model in the context itself. So again, the instruction could be typically based on, yeah, you did a good job, or like you got this reward. In the recommendation problem, they formulated the rec tuning instructions. So essentially here, the formulation becomes that you have the user history, and then you get a new item. And then you ask that, hey, what do you think? Will the user like it or not? Will the user have a positive or negative feedback? And once the model outputs, you provide a feedback that, hey, you did a good job or you didn't do a good job. So that feedback gets back to the model, and then you're fine-tuning the model based on this recommendation feedback. So now you can imagine, you can do some sequence learning, or like you can do a lot of like recommendation style in the recommendation problem, right? We have this feedback, which is the user liked it or not, and then we keep on updating the model and training the model accordingly. Now you can start doing that with the LLM model itself, right? And historically, people have done a lot of work on adaptation, like adapters essentially. So here, the goal was that you get the LLM, you do some low rank adaptation. Again, we're going to briefly talk about what adapters mean. Adapters typically are, you're adding these layers in between of your transformer models, and you're freezing the LLM model itself, but then you're adding these layers after each of these transformer layers, and then those are the parameters which you're updating for your task. And again, what's the update data? The updation is based on this feedback, which is the rec tuning part which you're doing. So again, this is the setup wherein you have the LLM, you're doing some instruction tuning, but on top of that, you're using this rec tuning samples which you have generated, and then rec tuning it as well. And essentially, if you want to do some instruction tuning, then typically what people do is they formulate it as a conditional language modeling objective, wherein you're maximizing the log of these probabilities, wherein X represents the instruction output, X represents the instruction input, Y represents the instruction output, and then you're maximizing the conditional probabilities over here. But in addition, so this is typically done in the non-RecSys scenario as well. Instruction tuning is like fairly common, but now because you're doing fine tuning as well based on recommendation tuples, you're adding this LoRa. LoRa is like low rank adapters, which introduce these trainable rank decomposition into each transformer layer. So that's typically almost common-ish now, because they allow LLMs to acquire these task-specific capabilities without affecting the original large model. And again, these are also like easier to train. And there's a lot of work which has gone into quantization techniques and like making fine-tuning very scalable, very efficient. But the key part over here is like you're using LoRa on top of the rec tuning data, right? Which is the new innovation here. And again, in terms of performance, looking at GRU-rec, looking at BERT, looking at SAS-rec, a bunch of these models, again, if you look at the instruction tuning, it may or may not work as well across domains, but then the moment you start doing rec tuning, the performance really increases. And the moment you start looking at rec tuning in addition with instruction tuning, then you're getting the best performance across the different models compared. So I think like rec tuning this here is a great way to improve the performance of these language models. So again, if you look at the increasing sophistication over here, right? What we've looked at is we looked at some very simple approaches. I'm not going to do anything at all with my LLM. I'm just going to query it. That's a zero-shot simple example. Hey, in terms of prompting, I can do a bit more non-trivial prompting. I can do some pairwise prompting and then get the outputs, arrange my rank list into a sequence based on that. Or I can do some tuning. Instruction tuning has been around. Fine tuning has been around. Let me do some rec tuning for my own task, right? So there you're starting to see some incremental sophistication in how people have been adopting it. Let's look at some of these things beyond. And very honestly, beyond is the phrase, I couldn't club these together and I just wanted to bring it out as well. So beyond is like getting developed on a week-by-week basis. We're going to look at two of these examples. One is on personalization, the other is just representations. So there's very nice work from the Alexa team at Amazon, again, very recently last month, which is talking about can we do personalization aware LLMs for recommendations, right? And again, this is a very nice setup, very similar to the mimicking the RecSys stack we had. It has 3 steps. In the first step, you're using natural language user profile generation. And the goal over here is that I can, again, given the user history, I can use an LLM to just generate a summary of user interest. Because LLMs work on language input, and I want to represent the users, I won't be using features. But then what I'll do is I'll use an LLM and say that, hey, generate a profile summary for me. And then I can use that summary in the prompt later on. Again, that gives me the user profile. Step 2 is that, okay, I have the user profile now. Give me a set of candidates. And again, the candidate generator is a step we saw in the first part of the talk as well. You have the corpus, your candidate generator, and then you have the ranker. So the candidate generator gives you a bunch of candidates to rank for this user. Now, one good part over here is because you're providing a specific list of candidates and you will be prompting the model to only rank and pick up from these candidates, it avoids these hallucination style problems, right? It's not going to try to cook up something of its own, which may or may not exist. So that's the step 2. And finally, the step 3 is that, hey, can I get a bunch of candidates, right? So the candidates generated based on recommendations would be based on the prompting you do, right? So I have the LLM generated user history, I have the generated profile. I can then provide a bunch of retrieved candidates and then put it all in the prompt and give that to the model for me to recommend. And again, a few examples here of the natural language user profile, which is generated, the items which are recommended, and then you provide this task instruction. And this instruction says that, hey, recommend 10 items based on user history and candidate list. You provide the user history based on the output of the previous LLM you used. You provide a bunch of candidates from the candidate generator, and then you get a bunch of outputs which you can use. So that's, again, right, this starts saying that, hey, you can now start personalizing it based on the user summaries and user features which you've generated. And the candidate retrieval, the candidate generator itself would be personalized because in a RecSys pipeline, the candidate generation is based on user and item features. Finally, let's look at something which is just out or accepted at RecSys this year, but I couldn't find the paper because I don't think it's like out there yet. Scott was somebody I interned with like way back 10 years ago almost. So he's spending some time at Google Research, and they've been investigating this problem of like representations, not about like just pure recommendation tasks, but then what sort of, if I have like user preferences, then will an LLM give me a good user representation, which I could use, which is better than the items and vectors which I've been using. So I think the result over here is like very promising. And I've included it because it's looking at one level deeper, right? Not just solving the recommendation problem, but then looking at one level deeper on, okay, can I start using them as good representations, and how these representations compared with the traditional collaborative filtering based item or vector representations I've been using. So here the output, the summary of this work was, the main result was that the LLMs are much better than state-of-the-art collaborative filtering models, wherein like you have language-based preferences in a cold start scenario, right? They work much better when compared with like item-based or like vector-based representations in general. So just let's take a step back, right? What we've looked at is, we looked at the entire RecSys stack, very simple corpus, candidate generated ranker. We've looked at like a few ways people have been thinking about the entire space of LLM for RecSys, discriminative, generative, and some of the recent work has started to look at zero-shot cases, looked at some of these prompting, pairwise prompting, look at tuning, but then tuning for recommendation problem, which is rec tuning, and then a bit of personalization, and then different representations. So before I conclude, a few thoughts which I wanted to share from at least like what I've observed, what I've read about, in general, some of the work which is going on in our teams as well. So this is like all non-scientific personal thoughts and reflections with like no data backing any of this. So take all of this with huge grains of salt, please. But again, I'm just going to go through them 4 or 5 bullet points to talk about some of these problems which we will face and we are starting to face now. And I think like we and the community are going to start figuring this out. So the first thing is corpus, right? The RecSys stack, the corpus candidate generated ranker. In the corpus land, I'm right now in my current role dealing with 100 million items per month. If you're Reels or if you're TikTok, if you're share chat, short videos, images, 100 million of them get generated on each of these platforms every month. And that is like user generated, right? Now, if you look at like generative AI, then like on each user interaction, you're generating content. The question is, again, of course, the corpus explodes, right? The question then becomes, what do you want to generate? Importantly, what do you want to index? Because right now, we're paying a lot of cost in terms of storage, like BQ storage or wherever you're storing it on GCP or wherever. So each of these items gets a representation. If it's a video, it gets like the video encoders, you're compressing the video, storing them. But then do you want to do that for each generated content? What sort of content do you want to index? How long do you want to store that content? Because again, you're going to incur a lot of storage costs. The corpus size is going to increase. If the corpus size is going to increase, then it's going to have a effect on the cost, on the latencies of your candidate generator, all of that. And again, if you look at the storage, like one of the problems we faced and we've solved internally at ShareChat was how long should the look back period be, right? If you look at music, then I want music from 300 years ago, why not? But then if you look at reels, maybe users are not consuming reels from 6 months ago. And most of the current generated reels are what's in trend, right? So again, there's a lot of trendiness on some of these platforms, and they're not storing content for like more than 6 months or more than like a month as well in some categories. Again, if you look at sports, like recent sports are far more important than 6-month-old scores from different cricket or football matches. So again, there's a lot of some of these problems on like what to generate, what to index, how long to store them, and can I, if I'm generating and then storing, then can I use them across users? Can I not use them? So there's a bunch of problems in the corpus side. Now, the other, again, the elephant in the room, right? Do we even need a ranking? Should I not just be generating the output as it is finally for the user? So there's a bunch of problems, bunch of thoughts which are going to come around in the ranking versus generation phase, right? This phase is just going to become more and more popular. If you haven't heard it up until now, then you've heard it now, that this is a phase which is going to just catch on. At least in the RecSys scenario, it's going to be like an aggregation of, not retyped, sorry, it's retrieved. Yeah. So I think it's a combination of looking at the aggregation of retrieved and generated candidates, and also eventually when we get comfortable, start doing the joint optimization of these ranking and generation models. Then in terms of interfaces, right, people are now getting used to intelligent interactions back and forth. So conversational RecSys has been around, but then the way you look at like a TikTok feed, that could be mimicking some interactions because it personalizes on the fly. If you look at the Netflix homepage, it may or may not dynamically rank content. But as and when users are evolving to expect intelligent interactions with these systems, then you'll start seeing, I'm hoping that we start seeing the redesign of these interfaces, that Netflix homepage becomes a lot more dynamic and it reacts real time based on what I'm doing. Now, just this interface expectation of being real time and being responsive, right, changes a lot of the paradigm on the RecSys stack. Because now it's not just about features and the common recommendation problems, but then it's about real-time features, real-time model updation, real-time embedding changes. And we've had some recent results at ShareChat and March on real-time embeddings giving us a lot of like good metric gains. So again, we're not waiting for embeddings to update after 24 hours, not even after 4 hours. Every few seconds when there are interactions, these systems are updating these embeddings, and these embeddings are now getting used immediately within 2 seconds across the candidate generator and rankers. So a lot of this kind of makes the entire RecSys, real-time RecSys pipeline very important going forward. The other area to touch upon is personalization, right? Because that's going to become more and more granular across 3 levels, right? In terms of user modeling, it's going to become a lot more detailed because now I have a lot of great insights on the language and the media understanding, like all the content you're interacting, not only like the topic, not only on what this video and image is about, but then like how many people are in this video, what's going on. I can do a lot more deeper semantic understanding of the content, and that enables me to develop much, much richer user models. At the same time, in terms of user intent-aware generation hasn't been looked upon just yet. Right now, we are okay with generating content for the prompt, right? Without looking at the personalization aspect, that, hey, this user really wanted it for this intent, and then that intent-aware generation or differentiation isn't there as prominently just yet. But then that said, intent understanding remains as important. If not more, it's going to become more and more important because you're going to look at the entire prompting, the response generation, all of that, keeping in mind the user intent. So I think some of these problems are going to become more important in general. But overall, you'll start seeing granularity increase a lot in terms of personalization because it becomes easier to personalize even minute details of the content which gets generated, especially because I can generate content. I know you don't like, let's say if you're looking at Pinterest and you're looking at a bunch of these images on home decor, I know you don't like tables which are black in color, right? You have preference for like rustic color. So then I can look at generate content which have like home decor and like tables which are like rustic color table, right? So I think the granularity of what can be personalized, especially keeping in mind that now I can generate content on the fly, also enables and unlocks that like more granular personalization. The other aspect over here is evaluation, right? Again, if you're talking about the RecSys problem, we not talk about evaluation. So there's some work which has started to come in. There's a very nice tool out there which says that, hey, you can start using these LLMs as user simulator, right? The user simulator, you can say that, hey, this is a user, this is a profile. Now tell me, will the user like it or not? And again, you can start using them to provide these soft labels, weak labels, if you may, to your typical training data set. But also very importantly and very differently, there's a feedback loop on the generation process, which is not as prominent today, right? It gets generated, but then the next time generation has to happen, the onus lies on us that, hey, give a different prompt, right? This onus of a better output right now is on the user, right? I think that's going to go back and change to the model that, hey, look, again, if you look at Spotify, I'll skip content. I'll skip the music track. Spotify will figure out that, hey, the user did not like it. But then I won't go back and re-query it. It figures out on its own. So I think that's the feedback loop, which is right now not as prominent in the generation process. With the feedback loops are all over the place. Again, they're very prominent in the entire search and recommendation industry. And that is something which starts getting added back to the generative modeling world. Again, there's a lot. This is a very strong understatement. The entire content and creator space is changing. Intense competition in the content markets, pushing creators to continuously enhance. The expectations on the user side is going to change. The trust aspect of what content is generated versus curated versus human generated, all of these are going to be like very different. The reason why I mentioned about creators is because in the current, at Share Chat, at Spotify, we've cared a lot about how do we benefit the creators in the marketplace lens. So I think there's a lot of implications on that, which again, this in itself could be a separate topic of discussion overall. So I think if you look at it, it's just a very small list of things which are about to change. But then if you look at the corpus and the ranking generation problem, these are two top things which are changing as we speak, because as and when these RecSys models are getting deployed, the industry is facing some of these problems as of today, as of last month. And there's a lot of work which is going on and which will continue to come in these topics. So that's a quick summary of where we are. And we're just in time with 3 minutes remaining. Just a quick background, we've just started to talk about like RecSys and LLMs, looking at the multi-stage RecSys stack, looking at the hierarchy of, hey, how do we think about the different generative and discriminative approaches of LLMs and RecSys working together. Looked at some 4 or 5 papers coming in recently in the last few months on how people have been doing prompting, how people have been doing tuning, Rex tuning, personalization, all of that, and then looked at some more implications on some different parts of the stack. So yeah, time for some questions if people want to stick around. And that's a quick summary. My personal email is here and available on Twitter. And again, as Barbara mentioned, we're going to be doing another run of the RecSys code, but this time we've spent a bit of time updating the course based on the recent literature. We haven't, again, since it's a short 45-minute session, we haven't gotten deep into the details of how the corpus and how the candidate generation, all of these techniques are changing in the LLM world. But then hopefully this just gives a trailer of what's going on in the RecSys community. And again, of course, a lot of people in the crowd have worked on these topics, have contributed to these topics, and may know a lot more than I do at this stage. So again, feel free to just unmute and have the conversation. Looking forward to your comments as well. Yeah, that's it from my side.
It looks like we have some questions in the Q&A. So David asked, which open source model would you recommend at this time?
Yeah, I mean, David, the easiest answer over here is the latest one, Llama 2 from the Meta, because again, I'm personally trying to use it. I haven't done any empirical comparisons, but just a recent biggest model commercially released, I think that's also an answer if I were to ask this question back to you. Again, if your answer differs, then yeah, I would love to hear from you as well. What you would be using.
Someone else asked, as formulated, a lot of these LLM RecSys approaches do not understand the content being ranked. Example, it has not been trained on videos, etc. How should we believe it as understanding user preferences in a true sense? Am I missing anything? Would you say any of these approaches is actually doing content understanding?
Yeah, that's a great question. I'm sad you didn't mention the name because people would love to know about you as well. And also Barbara and I organize these so that the community gets together, you get to know each other. Great question. I think like one insight which I have fairly commonly known now is that the zero shot, the reason why some of these models are doing good performance as zero shot is because your typical RecSys models don't have a lot of data in the zero shot scenario, right? But then if you train a large language model, it does know about that movie, it does know about that actor, it does know about that song or that label. So I think or any of these like videos or topics. So I think the default world understanding which these LLMs have do provide them, again, if there's an entity and that entity was present in the data set on which these models were trained on, and it can do a bit of extrapolation there. So then that is the default knowledge and understanding which these systems have. And that means that they have, at least once you tell it that, hey, the user has watched movie A, movie B, movie C, then what movie A means and what does it entail? It's leveraging its large scale training. These LLMs are pre-trained, right? So essentially the knowledge encoded in these parameters, the billions of parameters of these models, that encodes a lot of content understanding, which can then start impacting the performance, right? So I think like the way, again, the question is, are they really doing content understanding? Yes, they are doing content understanding, again, to the extent at which they understand what the content is, they understand what sort of metadata it might have. But is it the same content understanding as we would do if I were to train like a, let's say, a vision transform model, right? I train a vision transform model. Right now, this is what we are doing at ShareChat. We have vision transform models, we have the internal representations, we use them as features. We do some internal other deep neural models as well. And these are embeddings which I'm using as features in my recommendation model. Now, is this knowledge the same as a knowledge which an LLM encodes? Which one is richer? Which one is better? That's something which I think like future evaluations will churn that out. And maybe there are like papers already out there saying that LLM embeddings are much better content understanding vectors than the vision transformer or any other model you can create. So I think like there might be some of those studies which we can look into.
Rishabh, we have a few more questions. Do you have time to answer them? Should we answer one?
Yeah, we can take a couple of more questions.
Okay, awesome. Yeah. Neo said, in a scenario where it is expected the customers purchase the same or very similar items periodically, B2B supply, how would you add details such as features that translate frequency, amount purchase, etc., for the model to interpret, and how to avoid the prompt to explode in such cases?
Amazing question. Yeah, I think these are open questions, right? Again, this is not a domain I've worked with. So any idea, anything I would say is not backed by any data or any like scientific work at all. But I think like one of the key points here is that similar to what we've seen, right? The pairwise prompting or like the intelligent prompt design. If there are ways, if we know that these features are important in an e-commerce or some repeat purchase task, then maybe that is some feature extraction which we can do behind the scenes and then augment it, right? So this is where, if you look at in the industry, right, retrieval augmented generation, RAGs, that's fairly common now. Again, I keep saying this is fairly common when the entire world is just like few months old in the last 2-3 months. People are doing a lot of retrieval augmented generation. What that means is there's a bunch of metadata or knowledge which is outside of the LLM world, but then I can retrieve it based on the task at hand and then use that as a prompt, right? Now, how do we use it as prompt? There are like these context issues and all which you mentioned, but at least retrieval augmented generation is a current best approach, with all disclaimers, what best might mean today. But I think, yeah, if you're able to retrieve task-specific nuances and then use it as part of like prompt, that's a way to go. And I think this is where, if you look at not just retrieval augmented, but then like knowledge graph input to an LLM, right? There's a very nice GitHub repo. I don't have it handy. Maybe somebody has a link, they can share it. There's a very nice GitHub report talking about what's the integration of knowledge graphs and knowledge bases, knowledge graphs and LLMs, wherein people are using LLMs to populate knowledge graphs, and then they're using populated knowledge graphs to add information to the LLMs. So I think that's another example wherein you have some rich metadata outside of your LLM, which is task specific, and then you can start using it. Maybe you can take one last question and then.
Sure. And if you have questions, again, Rishabh will be teaching a 4-week course starting in a couple weeks, and that will include moments of questions, AMA, etc. One person asked, what about discriminative LLM? There's a lot of focus on generative one. Is there any sign it can work well with LLM?
Yeah, I think discriminative LLMs is a lot of papers, right? Before this year, if you read RecSys, BERT, I think it's fairly standard now. People are using some sort of like BERT embeddings or some sequential model. Again, if you look at the discriminative LLM, like BERT is a typical poster child example, which is fairly commonly known in the industry. So there, what people would do is, I have these BERT embeddings. Now the BERT embeddings should be of content, it could be of like user sequences as well. Again, there's nobody saying that you can only use word-to-vec on text. No, people have used word-to-vec on track sequences. Spotify has these embeddings which you're learning internally based on a sentence as a playlist, which is a combination of tracks, right? So to train some of these BERT models, you can adapt it to the recommendation problem, saying that, hey, I have these user sequences, historical interaction behavior, and then I can train a BERT embedding of these users or these items based on that. So I think there's a lot of work which has gone in I think the link of the survey which I posted, it has like close to 20 plus papers on how people have exploited BERT embeddings for downstream tasks. So yeah, there's a lot of like amazing work which has gone. I think the recent bias in this talk specifically is on generative front, because right now the LLMs have been around for a while. Again, a while means like a few years, not like a decades. But the recent focus has been on generative models. And that's why, at least in this talk, we've intentionally focused a bit more on generative and not discriminative.
Oh, awesome. I think that's time. If your questions weren't answered, we apologize, but you can find Rishabh and other formats on CoRise. Thank you all for joining us. Thank you, Rishabh, for your
Yes,
time.
and we're also, I think there's a Slack as well. There's a good enough reason for you to join the CoRise Slack as well.
Exactly. And hopefully we'll see you soon in Rishabh's upcoming course. And if not, on Slack. Bye, everyone. Thank you.
Thanks so much. See you. Bye.